Alright, hi guys. Here we are doing section 2.6, which is graphing rationals, and this would be something that you have some familiarity with because you did do it in Algebra 2 last year. First things, just remember that a rational expression is one of the form y equals 1 over x. And as we learned in chapter 1, because that was one of our parent functions, those graphs have asymptotes. In other words, 1 over x look like this. And an asymptote is a number that the graph approaches but never actually equals. So if you notice, this part of the graph right here goes towards y equals 0, but it never quite touches it. This part of the graph right here goes towards x equals 0, but it never actually touches. So it has asymptotes at x equals 0 and y equals 0. So first thing we want to do is figure out where those asymptotes are. And it's a pretty simple process. Wherever the denominator equals 0, that's where a vertical asymptote is, because you can't have a 0 in the denominator. So the process of finding it is taking the denominator and set it not equal to 0. That's going to tell you where your vertical asymptote is, and that's also going to tell you what your domain is. Alright. So here I have some examples for us to work on. And what we want to do is figure out where those vertical asymptotes are. So in the case of this first one, it's pretty simple. X minus 2 cannot equal 0, which means that x cannot equal 2. So your vertical asymptote is at x equals 2, or you could just write your vertical asymptote is at 2, and your domain is all real numbers, but x cannot equal 2. So that's a very easy example. This, you just take the denominator and set it not equal to 0, and there's nothing more to do. In example 2, though, we would need to factor. So the denominator factors to x minus 3, x plus 2, and that cannot equal 0. So again, it's not all that difficult. X cannot equal negative 2 or 3. So your vertical asymptote is at negative 2 and 3, and your domain is all reals, but x cannot equal negative 2 or 3. And the last one factors out to x plus 1, x minus 1, which means x cannot equal plus or minus 1. And your vertical asymptotes are at negative 1 and 1. Your domain, all reals, but x cannot equal negative 1 or positive 1. So hopefully you agree that finding the asymptotes is really a fairly simple process. Horizontal asymptotes are a little bit different because there's three different scenarios that we have to concern ourselves with. It has to do with the powers of the variables in the numerator and in the denominator. In the first case, the power in the denominator is greater. And this is probably more typical than your other possibilities. So if you notice in the example that I have here, power on top is 1, the power on top is 2. So the denominator has the greatest power, and if that's the case, the horizontal asymptote is always at y equals 0. Another possibility is that the power is equal in the numerator and the denominator. So first the denominator is greater, now they're equal. If you look at this expression right here, the highest power on top is 2, the highest power in the denominator is 2. Whenever that happens, the horizontal asymptote is the ratio of the coefficients of those two powers. So in the numerator we have 3x squared plus 2. The coefficient is 3. In the denominator we have x squared minus 4. The coefficient is 1. So that means the horizontal asymptote is at 3 over 1, which is just 3. Now before I continue on, just want to remind you of what we're talking about with these horizontal asymptotes. If the horizontal asymptote is at y equals 3, then there's this imaginary line right there that the graph does not cross. So maybe it looks like this. But it does not cross this dotted line. Some of them you'll find out actually do, because the excuse me, the actual definition of an asymptote is the number that the graph approaches as x approaches infinity or negative infinity. So in other words, it's approaching that dotted line way out there and way out there. You will see some graphs that actually cross that dotted line in the middle there, and we'll talk about those later. Those are some strange equations. So we talked about when the power in the denominator was greater. We talked about when the power was equal. So naturally the last possibility is that the numerator is the greater power. For example, 3x squared over x. When that happens, the asymptote is actually a slant asymptote. So instead of a horizontal line, maybe it looks like this, and your graph looks like this. That's something that we need to cover in another video. For right now, we're just dealing with scenarios 1 and 2, whether the denominator is greater or they're both equal to each other. Alright, so in this next set of problems, I want to know where is the horizontal asymptote. Well, in the first case, oh, actually I'm looking for the vertical and horizontal. In the first case, the vertical, we take the denominator and set it not equal to 0. Well, that means that the vertical asymptote is at 4/3. Scratch that. 3/4. The horizontal asymptote depends on the powers. Power in the denominator is 1, the numerator is 0. So since the denominator is greater, the horizontal asymptote is at 0. Y equals 0. So, why don't you guys try B, C, and D? Pause the video while you give that a try. Okay, letter B. Take the denominator, set it not equal to 0, and you're going to end up with a plus or minus 4i here. Well, that tells you that there is no vertical asymptote. As for the horizontal, we have a 2 on bottom, a power of 1 on top, so it's just 0. C, 2x plus 1 cannot equal 0, which means x cannot equal negative 1/2. Vertical asymptote at negative 1/2. The power on top is 1, the power on bottom is 1. Okay, if the powers are the same, then it's a ratio of the coefficients, which in this case would be 4 over 2. 4 over 2, which is 2. And letter D, the denominator factors out to x plus 9, x minus 4. So your vertical asymptotes, well, before I do that, we need to factor out the numerator if we can too, because there's a chance that things could cancel. Alright, so that's going to be actually a plus there and a minus there. Okay, what happens if something cancels is that it still can't be at that spot, but all it is a hole. Now, I don't know if we're going to have that type of situation in this class, but you will in calculus. So we know that the vertical asymptotes are at negative 9 and 4. And since we have an x squared over x squared, the horizontal asymptote is at 3 over 1, or just 3. Alright, so that's how you figure out the horizontal asymptotes and the vertical asymptotes and the domain of these types of functions. I'm going to stop the video there, and our next one is going to be on graphing these types of problems.